The success of the world leaders in citrus production is due to innovations in production technologies and management. These strategies have led to a notable shift in orchard productivity. In 1980, Brazil growers produced 500 boxes per hectare. Today, the yield is 1,600, an increase of more than 300%. The Brazilian track record is admirable and is a testimony to their diligence and the importance of continued research and innovation adoptions to achieve success. Brazil is a world leader in citriculture innovations and exports 97% of its orange as frozen concentrate. 3 out of every 5 glasses of orange juice consumed in the world are produced in Brazil. The Brazilians gained a competitive edge by fine-tuning and engineering every aspect of the industry, with specific emphasis on the human element. Research institutions and production companies have partnered with stakeholders along all aspects of the production chain to ensure adoption of best practices. Emphasis on selecting the best locations, orchard orientation, field layout, understanding the influence of soil type and fertilizer application, water availability and infrastructure for mechanization were all key to the industry's success. For the Caribbean to become competitive, these elements must be embraced as well. The subtropics have been highlighted as the optimal area for growing citrus. It's no small wonder that the large citrus producers, China, USA, and South America, are in this hemisphere. Oranges grown in the cool subtropics develop an attractive deep orange color and thicker skin. These areas, however, are prone to frost damage, unlike the Caribbean and other tropical areas that are not at risk from frost injury. However, the oranges in the warm tropical regions are often green. But don't let the green color fool you. The green color is no indication of flavor. In fact, some green colored fruit has more sugar than the more deep orange fruit. The increased chlorophyll allows the fruit to photosynthesize and create more sugars in its pulp. Climate has great influence on the vigor and longevity of the trees, as well as the quality and quantity of the fruit. Citrus trees are best adapted to climates with high relative humidity and temperatures ranging between 23 to 32 degrees Celsius. It has long been established that fruit grown in humid areas has a thinner peel than those grown in arid areas with low relative humidity. In general, fruit produced in hot desert climates are thicker peeled and less juicy than those grown in the hot, wet climate such as the Caribbean. The relatively high night temperatures in the tropics result in low acid fruit, while fruit produced in subtropical areas with low night temperatures are highly acidic. Citrus can be grown on virtually any terrain, but mechanization is better suited on flatlands or on slopes of up to 15 degrees gradient. On steeper slopes, stringent conservation measures must be implemented to reduce the risk of erosion and operate machinery safely. Citrus trees require a minimum of 60 centimeters of well-drained topsoil, but a depth of 1 meter is preferable. Loams and sandy loams are preferred. Very sandy soils require expert management and irrigation, as they have a low water holding capacity and nutrients are easily leached. Wetter clay soils need to be cambered to reduce waterlogging and tree death. A soil pH between 6 and 6.5 is required. Avoid soils with a pH above 8. In citrus, an effective fertilization program is essential for fruit quality and yield. To ensure optimum yield, a detailed soil analysis should be conducted before planting.
Fertility management is a key component of citrus production, not only for yield, but also for citrus quality. There are 3 elements of fertility management of importance to the grower: soil analysis, plant tissue analysis, and nutrient deficiency and toxicity symptom identification. Soil analysis entails getting an understanding of the nutrient supplying power of our soils, as well as any physical impediments that may need addressing during land preparation. Plant tissue analysis gives us an idea of the concentrations of nutrients actually in the plant that is directly related to our yield and quality. Lastly, plant tissue nutrient identification entails being able to determine whether or not there are symptoms of toxicity and or deficiency in our citrus grove. This is done by observing our plants, especially our young citrus leaves, in determining various facets of nutrient deficiency or toxicity symptoms. Combine the three elements gives the grower a very strong opportunity for guaranteeing not only potential yield but excellent quality.
The availability of soil macronutrients play a significant role on fruit size, fruit quantity, and quality of the juice. The Brazilians have incorporated regular soil testing as an integral part of their production practice.
We sample the soil each 2 years to determine the total amount of fertilizers that we will apply in the grove. But if you don't have the sample, use the last one. It's better to base in an old one than to base on nothing.
The elements of fertility management are important in ensuring that appropriate amounts of fertilizers are applied, particularly to the newly established citrus grove. Over-application of fertilizer may result not only in toxicities and reduced productivity of your citrus grove, but may also result in environmental deterioration. To ensure that appropriate quantities of fertilizer are applied, the key and most principal factor of importance is soil testing, particularly if you have a very newly established orchard. Soil testing would determine the elements present in our soil, as well as ensuring that the quantities of fertilizers applied are appropriate for the establishment of our citrus grove.
Nitrogen is one of the most critical nutrients for increasing citrus tree growth and crop yield. It is no small wonder that it is the nutrient most likely to limit yield and quality of the fruit. The greenleaf pigment chlorophyll, which enables plants to make sugars from sunlight, carbon dioxide, and water, is a nitrogenous compound. Low availability of nitrogen will result in yellowing of the leaves, reduced growth, and lowered crop yield. Too much nitrogen with too little potassium can result in the plant being susceptible to diseases, reduce photosynthesis, reduce fruiting, and fruit drop. Excessive nitrogen can affect fruit quality by lowered fruit quality and shortened storage life, decline in the quantity and quality of the juice, decreased fruit size, increased peel thickness, increased incidence of creasing, especially among mandarin cultivars. Creasing is a major rind disorder of mature navel oranges in particular. Potassium is second only to nitrogen as a macronutrient and is a key element in fruit production and quality. While nitrogen is essential to chlorophyll formation, potassium helps regulate the carbon dioxide supply for photosynthesis by controlling the stomata opening and closing. The rate of photosynthesis drops sharply when plants are potassium deficient. The reduced photosynthesis can result in lost crop yield and quality. A most serious disadvantage of excessive potassium is a direct and strong link with juice acidity. Phosphorus stimulates early growth and root formation and is very important to the early development of the plant. In the long term, regular phosphorus applications will maintain the yield and fruit quality of mature trees. Supplying sufficient tree nutrition should be a high priority management practice for every citrus grower. Achieving optimum citrus nutrition through fertilizer management involves the proper balance of plant nutrients. If an element is below the critical level, yield production will fall, even though the other elements are kept in good supply. Balanced use of plant nutrient corrects nutrition deficiency and toxicities, improves soil fertility, increases nutrient and water use efficiencies, enhances crop yields and fruit quality, and develops tree tolerance to pests, diseases, and other stresses. Citrus trees require a properly designed and operated water management system. Proper irrigation improves fertilizer uptake. Citrus trees with sufficient water and nutrients grow stronger, better tolerate pests, withstand high temperatures, yield more consistently, and produce good quality fruit. In the Caribbean, plantations have been rain-fed and use spacings established since the early years of citrus production. These factors do not optimize productivity per unit area. Fertilizer applications are done by general recommendations rather than plant requirements and soil nutrient availability. We have seen the importance of mineral availability on fruit yield and quality. Therefore, application of fertilizers without understanding the availability of soil nutrients can compromise production, juice quality, and plant health. Return on investment begins after the third year of the tree's life, and a tree has an average productive lifespan of 20 years. Profitability is dependent on economies of scale and planning strategies. To improve economies of scale and yield, Brazilians have increased density per hectare from 250 trees per hectare in the 1980s to 360 in the 1990s to 476 in 2000 and now 850 trees per hectare, an increase of more than 340%.
The best spacing, it was 7 per 2 meters as a control. And then we start to reduce the spacing between rows. Then we have here 7 per 2, 6 per 2, 5 per 2, 4 per 2. We can see the 4 per 2, and we can note the difference. And obviously, this trial is proving our first observation. Because some people say, in general, that the high density plantings only works on irrigated groves. But we are proving that it's not true.
It is estimated under proper conditions, each tree should yield approximately 320 kilograms per season. Compared to 30 years ago, production systems have changed dramatically. In addition to increased densities, better agronomy has been implemented, including the preparation and hardening of healthy, disease-free young plants grown in screen houses and transferred to the fields 1 year after grafting. The graft plants are fitted with high-yielding desirable scion, grafted onto a range of rootstock, tolerant to the specific conditions under which the crop will be established. The US has one of the highest yields per hectare, producing 31 tons per hectare, based on better technology and 100 years of citrus nursery certification programs. The maintenance of the fruit industry and establishing new orchards is dependent upon regular availability of healthy and disease-free plant material. Most of the desirable scion cultivars in citrus are susceptible to soil-borne threats and are therefore grafted onto tolerant-resistant rootstocks to provide a stronger dwarf plants with an efficient root system. Grow-out of plants in screen houses improves the survivability and vigor of the young graft plants. Screen houses offer several advantages. The nursery can be set up almost anywhere, and the plants can be propagated in areas with poor soil and water availability. Container grown plants are easily portable without disturbing the plant root system. Potting media used is nutrient rich and free of soil borne pests and diseases. This has the added advantage of reducing the spread of soil borne diseases from nursery to the orchards. Container grown nursery is less labor intensive and provides absolute weed control. Because of all these advantages, the concept of container grown nursery is becoming more popular. Development institutions should support the establishment of private certified plant nurseries to facilitate progressive growers and nursery owners to establish this highly lucrative business as a future industry. Growers may consider mixed season varieties to reduce price risk and lengthen the availability of fruits throughout the year. Citrus growers must discern between quality factors for the fresh and processing markets. For example, fruit size, shape, color, and maturity date are most important for fresh fruit, but high juice content and soluble solids are desirable for processing fruit. Fruit quality is affected by several factors, including cultivar, rootstock, climate, soil, pest, irrigation, and nutrition. As we look to re-engineer the industry, we must retool the labor force to be more technical and proficient at on-farm operations, as well as crop agronomy. Employ more technology and mechanization to improve efficiencies while reducing labor requirements. Bed designs and infrastructure must support the introduction of field mechanization. Our industry is in need of change, and the vision of the farming community must meet the realities of the world market. The Caribbean has a valuable product that can sustain or at least supplement our needs, but we must change our approach and engage in effective and sustainable economic and agronomic practices to survive.